So today we're going to be talking about microbial nutrition and growth. This is chapter 9 in the textbook. Microbial nutrition and growth is an essential topic in microbiology that helps us to understand how microorganisms survive and reproduce and thrive in different environments. Microbes, despite their microscopic size, do play a significant role in nature, medicine, and industry. Next, we're going to be talking about what is microbial nutrition. Microbial nutrition refers to the way that microorganisms obtain the chemical substances needed to sustain life. Just like humans, they need carbohydrates, proteins, and vitamins. They require essential nutrients to grow and function. These nutrients can be divided into two main categories: micronutrients and macronutrients. Macronutrients are required in large amounts because they provide the basic building blocks for microbial cells. The most important macronutrients include carbon, nitrogen, hydrogen and oxygen, and phosphorus, like we saw in the last slides. Micronutrients, or trace elements, are needed in small amounts but are essential for enzyme function and maintaining cell stability. Examples include iron, zinc, manganese, nickel, things like that. All right. Microbes have different ways of obtaining these nutrients depending on their environment and their metabolic capabilities. First, before we talk about that, we're going to go into the chemical analysis of microbial cytoplasm. We know that water is the most abundant of all the components. It makes up about 70% of the cell contents. Proteins are the next prevalent chemical, and about 97% of the dry cell weight is composed of organic compounds. Again, we talked about the carbon, the hydrogen, the oxygen, the nitrogen, the phosphorus, and the sulfur being critical in those microorganisms and cells. All right, we're going to talk about the heterotrophs versus the autotrophs. So again, microbes have evolved in different strategies to obtain nutrients based on where they live. There are three main ways that they acquire the necessary chemicals for survival. Again, let's talk about the heterotrophs first. These microbes obtain living organic compounds from other living or dead organisms. Most bacteria, fungi, and protozoa fall into this category. Heterotrophs are dependent on other life forms versus autotrophs that are not. And among the common organic molecules that can satisfy this element are proteins, carbohydrates, lipids, and nucleic acids. All right, let's go on to the autotrophs. These microbes can make their own organic compounds from carbon dioxide or CO2. Like we just said, they can be photoautotrophs, using light energy, or chemoautotrophs using organic chemicals. They do have the special capacity to convert CO2 into organic compounds. And again, like I've said for about the third time, they are not nutritionally dependent on other living organisms, and that's where the name self-feeder comes from. All right, nutritional types are how microbes feed. Microbes take in nutrients using various transport mechanisms. But first, we're going to talk about how microbes feed in nutritional types. The bacteria are subdivided according to their energy sources as phototrophs or chemotrophs. And microbes that photosynthesize energy are phototrophs. Chemotrophs, like I said previously, are those that gain their energy from chemical compounds. All right, chemoautotrophs are of two types. One of these is the group called chemoorganic autotrophs. These use organic compounds for energy and inorganic compounds as a carbon source. The second type of chemoautotroph is a group called chemolithoautotrophs, which is such a huge word. These require neither sunlight nor organic nutrients, relying totally on inorganic materials. An interesting group of chemoorganic autotrophs is the methanogens, which produce methane or CH4 from hydrogen gas and carbon dioxide. All right, here we've got a picture of the autotrophs, and we've got a photoautotroph versus a chemoautotroph here. All right, let's go into the movement of molecules here, diffusion and transport. We're also going to talk about passive transport as well. They do take in nutrients using various transport mechanisms. You've got passive transport that requires no energy. Nutrients move from a high to low concentration, and examples of this include diffusion and facilitated diffusion. You also have active transport. This requires energy, or ATP, to move nutrients against their concentration or gradient. This is how microbes ensure that they acquire essential nutrients even when the environment has low concentrations. We're going to talk a little bit about endocytosis too. Now, endocytosis only happens in eukaryotic microbes. Some protozoa engulf nutrients through the processes like phagocytosis, which is solid particles, and then pinocytosis, which are liquids. The driving force of transport is natural atomic and molecular movement, the tendency of atoms and molecules to be in constant random motion. Again, coming back to diffusion, it is the phenomenon of molecular movement in which atoms or molecules move in a gradient from an area of higher density or concentration to an area of lower density or concentration. Here we have a picture of diffusion. Let me kind of move myself here just to kind of show you what that looks like. So we can see here that the particles are going from an area of higher density or higher concentration to an area of lower density or lower concentration. All right, back to osmosis. Diffusion of water through a selectively permeable membrane is a process called osmosis. In an osmotic system, the membrane is selectively or differentially permeable with passageways that allow the free diffusion of water but block certain other dissolved molecules. And I just kind of wanted to show you the difference between the diffusion and the osmosis here in picture form. All right, environmental factors that influence microbes. Once microbes have the nutrients that they need, they can grow and multiply, but microbial growth refers not just to the increase in cell size, but more importantly to the increase in cell number. For example, bacteria typically reproduce through binary fission, where one cell divides into two identical daughter cells. Microbes are also exposed to a wide variety of environmental factors in addition to nutrients. Microbial ecology focuses on ways that microorganisms deal with and adapt to such as factors as heat, cold, gases, radiation, osmotic and hydrostatic pressures, and even other microbes. Let me kind of move myself. Ooh, a little bit of technical difficulty here. Let me kind of move myself so you can see that. Each microbe has 3 cardinal temperatures: its minimum temperature, its optimum temperature, and its maximum temperature. All right, so going on to talk about the temperatures in these microbes. With regard to their temperature requirements, microorganisms are classified as psychrophiles, mesophiles, and thermophiles. Organisms that can withstand very harsh environments are called extremophiles. And here you can kind of see the picture I have here, just differentiating each of those different things here. All right, we're going to go on to talk about gases and how microbes process oxygen. The atmospheric gases that most influence microbial growth are oxygen and CO2. Of these, oxygen has the greatest impact on microbial growth. There are several different named categories of oxygen requirements. We're going to talk about aerobes, anaerobes, but first, an anaerobe can use gaseous oxygen in its metabolism and possess the enzymes needed to process toxic oxygen products. An organism that must have oxygen is an obligate aerobe. A facultative anaerobe is a microbe that does not require oxygen for its metabolism and is capable of growth in the absence of it. We're going to continue on and talk about, and I hope I'm saying this right, but a microaerophile does not grow at normal atmospheric concentrations of oxygen, but requires a small amount of it in its metabolism. An anaerobe, and we know that that prefix right there, and lacks the metabolic enzyme systems for using oxygen in respiration. Because obligate anaerobes lack the enzymes for processing toxic oxygen, they cannot tolerate any free oxygen in the immediate environment and will die if exposed to it. Aerotolerant anaerobes do not utilize oxygen but can survive and grow to a limited extent in its presence. A few key points that we haven't went over yet. Microorganisms generally live in association with many organisms. Their relationships usually range from mutualism to parasitism to antagonism and may shift over time as resources shift. Biofilms are complex synergistic communities of microbes that behave differently than free-living organisms. All right, we're going to talk about the study of microbial growth. When bacteria are grown in a controlled environment, such as a laboratory culture, they follow a predictable pattern called the bacterial growth curve, which does consist of 4 phases, and we're going to kind of talk about that here shortly. I did kind of go over binary fission, but I want to go over that again. When microbes are provided with nutrients and the required environmental factors, they become metabolically active and grow. Microbial growth refers to not just the increase in cell size, but most importantly, the increase in cell number. Bacteria, for example, typically reproduce through binary fission, where one cell divides into 2 identical daughter cells. And you can kind of see, I know this picture right here is a little bit small, but you can kind of see what that looks like in binary fission. All right, here we've got the population growth curve, and we're going to be talking about the lag phase, the exponential phase, the stationary phase, and the death phase here. Again, when they are grown in a laboratory culture, they do follow that bacterial growth curve, and I kind of put this picture up here for you to see right now. All right, so let's talk about the growth phases of microbes. The first phase of that is the lag phase. That's where the microbes are adjusting to their new environment. They are metabolically active, but they are not dividing yet. The log or exponential phase is the rapid growth phase where cells divide at their maximum rate. During this phase, nutrients are abundant and waste is minimal. We're going to go on to the stationary phase. That's where the growth slows down as nutrients become limited and waste products accumulate. The number of new cells produced is equal to the number of cells dying. And then the death phase is when the conditions start to worsen and the cells begin to die at an increasing rate. Some bacteria can form endospores, which allow them to survive in harsh conditions. All right, we're going to kind of go back and touch on the factors affecting microbial growth. I know I kind of hit that before, but microbial growth is influenced by several environmental factors, including temperature. And, we went over the psychrophiles, we went over the mesophiles, the thermophiles, and the hyperthermophiles. Also, pH levels are something else to kind of think about when we're talking about microbial growth, as far as oxygen requirements as well. We're also going to talk about moisture, because water is essential for microbial metabolism, and many microbes cannot grow in these dry conditions. And then nutrient availability and salinity. Let's go on to the conclusion and the importance of understanding microbial nutrition and growth. When we study the microbial nutrition and growth, it is crucial for many applications, including medicine, the food industry, the biotechnology, and then the environmental science. In medicine, you kind of understand how pathogens grow and help develop antibiotics and treatments. As far as the food industry, you are controlling microbial growth for food preservation and preventing spoilage, and we know in this day and time that's pretty important. We're also talking about biotechnology, and we know that microbes are used to produce antibiotics, vaccines, and biofuels. That's also a big one. And then as far as environmental science, microbes help recycle nutrients and decompose organic matter. So in conclusion, microbial nutrition and growth are fundamental concepts in microbiology that impact various aspects of life, from health to industry. They require specific nutrients to survive, and their growth is influenced by environmental conditions, like we talked about, like the pH, like the temperature, the salinity, all that good stuff. By studying this, we can better control harmful microbes while harnessing beneficial ones for science and medicine. That is the end of my presentation, and I appreciate you guys for watching. Thanks. Have a great day.